Let's begin with left shift operator. It is represented with this symbol. Consider an example like say 5 left shifted by 2. So the step 1 which we need to do is to convert the number 5, which is an integer, to binary code. I hope you might know how to convert. If you don't know, let me explain. You just simply need to divide it with 2, so you get remainders like 1, 0, 1. The values of the remainder from bottom to top is written as our binary code. Now 1, 0, 1 is left shifted by 2. Where the number 2 represents the number of places where the binary code should be shifted. Now the binary code 101 is left shifted. This is just for your understanding. You have to write the numbers and then write the 0. Again, whenever you shift it again, you will be writing 0. So the tip is the number of places you need to shift, you already know. So write the number of zeros. Here we have 2, we have to write 2 zeros. So in this way, you can write it easily and quickly as well. Hence, we get this binary code. The next step is step 2 to convert the binary code into decimal. And let's see how we can convert it. So write the binary code again. So from right to left, this is right and this is left. Now we need to multiply it with 2 to the power of position. Here we have 0, 1, 2, 3, and 4. So if I write it clearly, so if we get the values like 16 and 8 and then 4, 2 and 1, we have to multiply these values with this code. After multiplying, we get 0, 0, 4 and then 0 and then 16. We need to add these, we will get 20, and this is our final output. Let's code this thing. Now let's try to apply these concepts in our code. We will be writing num as 5 and we will be shifting it to 2 places, that is 2. So the result is nothing but num left shifted to shift. So printf and %d is used for integers so that the values we will be getting in integer format. So let's see the result. We got 20 successfully, yay! We did it. Now let's try to understand right shift operator, and it is represented something like Sunia's face. Just kidding. This is how it looks. Now let's consider the same example which we have used in left shift operator. So the step 1 is same. We need to convert number 5, which is an integer, into binary code. And I guess now till now you got it, how to convert it. So I'm writing it directly. So the binary code of 5 is, I guess you remember, it's 101. Yeah. So we'll be right shifting it by 2. And how? Let's see. Now the binary code 101 is shifted to the right side. We'll be writing 0 in the number of shifting places. So here in this case, you need to remember one thing, and that's very crucial. So the tip is, here you need to write the binary code 101 by placing the zeros, which are 2. We have to forget the remaining 2 whenever we are writing another 2 numbers, which are 0. So first we'll be writing 0 in the beginning, and then we'll be forgetting the remaining 2 which we already had. So this is the right way of writing the binary code. Now the step 2 is we need to convert, or we need to write the decimal by converting this binary code. So first write the binary code as it is, and then from right to left we'll be writing 2 to the power 0 to 1 and 2, and then we'll get these values. We get the number 1 as our output. We got 1 as our output. Let's try to code this. Okay, so without wasting our time, I'm gonna just replace the left shifted to right shifted. Similarly here as well. So by running the code, we get the output 1 as expected. Now let's try to learn AND operator, and it is represented like this. Now let's consider an example of A as 10 and B as 12. So the first step is to convert these two numbers into binary code. I hope till now you understood how to write the binary code of any integers, whichever come across to you. So the binary code for 10 is 1010, and for 12 we'll be getting 1100. So after writing the binary codes of these two numbers, we will be doing step 2, and that is to apply AND operator in between these two numbers. So we need to apply AND operator, and let's see how we can do it. So basically we have A, which is this 1 0 1 0, and then B, we got 1 1 0 0. So we need to apply AND operator in between these two, which is nothing but A and B. If you heard the logic gates, that is AND logic gate, you might know this thing, that is A into B or something A dot B. So it's the same thing actually, even in this code as well. So we will be writing 1 0 0 and 0. So basically wherever you find 0, it will be 0, and where you find 1 into 1, it will be 1. I know, even if you don't know, it's okay. So write it even if you don't understand in this format also, it will be the same thing. So basically it depends on whichever way you want to present it. Now the step 3 is to convert this binary code into decimal. You've got this. So with the same procedure from right to left, we will be converting into decimal, which is the same old procedure. So you're going to get 8, and all are zeros whenever you add this up. So you just have to multiply and then add it. We get 8 as our output. Let's find this out in code. So let's try to check this out. So I'm gonna write the same thing, A as 10 and B as 12, and by using the AND operator, A and B, we will be using this percentage D whenever we need integer output. So yeah, let's try to run this out. We got 8. We did it. Yay. Now let's try to understand OR operator. I'm going to use the same example which we have already discussed in the AND operator. So the step 1 is to write the binary code, and here I'm writing the same code since we have already discussed in the AND operator. So, and here's the code. Now the step 2 is to apply OR operator. If you heard the OR logic gate operator, you might know this as A plus B. So I'm gonna use the same thing here. So write it as it is like this, and then you can also write it in this way, like A as 1 and then B and all those values, and then add them up and you get 1 plus 1 1, and then 0 plus 1 1. This is the operator, basically the same. You don't need to write the plus here. So next, the step 3 is to write the binary code into decimal. So in this OR operator also, we'll be doing it from right to left. So 2 to the power of 0 from right to left. And we'll get the values 0, 2, and then 4, and then 8. We'll be adding them. We'll get 14. And this should be our output, and this will be our output. So we have the same example. I'm just going to change the AND operator to OR operator. So let's see. The output is 14 as expected. Now let's try to understand the XOR operator. I'm going to explain it by differentiating with OR operator. And this is a symbol. It will be the same thing, just a little change. You have to write the binary code. That's step 1. So this is basically similar to OR operator, but not exactly the same. So I'm going to use the same example in XOR as well. So I'm writing the same code, A and B 1100. So in XOR operator, the same things, the same things, nothing but you'll understand, same things should be 0 and different things should be equal to 1. Here we have 1 and 1, which are same. So 1 XOR 1 will be 0, and these are different, so that will be 1 and 1 and 0. So next, step 2 is to use the XOR operator, which we have done. Now the step 3 is to convert the binary code to decimal. So especially in XOR operator, we need to be careful in this step. So listen carefully. We need to write the decimal by following this rule. So we write the decimal by following from left to right. I hope you got this point. Listen carefully. So usually till now we have done from right to left. That's why I have trying to compare it with OR operator. But now in XOR we will be doing from left to right. So we will be writing this code again. So from left to right we will be starting with 2 to the power of 0. So from left we will be writing 2 to the power 0, and then further increasing 1, 2, and then 3. So I hope you got this. Now same procedure, just write it. You get plus 2 and then plus 4 into 1 and then 4 and then 2 cube 8 into 0, nothing but 0. So you'll get 6. So 6 should be our output and it will be. Now let's try to understand this in the code. So previously we have done the OR operator. I'm just replacing it with XOR operator. So we will be getting 6. Here we go. Now our final topic is to understand NOT operator. Let's try to understand it. This is the symbol of it. It's like a wave. Okay. It is used only for single variables. So it is used only for single variables. Consider this example like let's say a equal to 5. So what we exactly do in NOT operator. So first of all, the basic thing is to convert the number to binary code. So by converting it, we will be getting the binary code as 101. So using NOT operator, whenever we use NOT operator for the number 1, we interchange it with 0, and for 0 we write it as 1. So here we have uh, 0 1 0, but basically we need to know one thing. My bad, sorry. So here we have 1. So 1 represents negative value in any binary code which is in the leftmost. So we have to write it in the format 0 extra for the left side. So we will be writing 0 1 0 1, and then by converting it into NOT operator, we'll be getting it 1 in the place of 0, and then so we have got again 1. So we need to interchange the last two, which is 1 0 2 0 1. So this is a correct way of writing the NOT operator. I hope you're understanding it. Even if you don't understand, please rewatch it. So the step 2 is to convert the binary code into decimal. So here we have to do the same thing which we used to do in all the operators excluding the XOR. Again, we need to check it from right to left. So only in XOR we will be checking from left to right. So what we got is 4 plus 2, which is nothing but 6, but here we have 1 in the leftmost value, so we will be having negative value. So minus 6 is our final output. Here we go. Yay, we did it. Now let's check the final code. Here we have a equal to 5 and not a is nothing but we write it like this, and then not operation on a. So let's try to run this code. Okay, here we go. We got minus 6 as expected. So finally we have covered all the bitwise operators with the code and with the examples, and I hope you understood. Thanks for watching.